Objective 2. Compute the variance for a set of data. Although the range is easy to calculate, there are a couple of downfalls to the range. The first is that it is very sensitive to outliers. Second, it only takes into account 2 of the observations. That is why we will discuss the variance and the standard deviation, since it is less sensitive to outliers and takes into account all of the observations. The variance of n observations of x subscript 1 all the way to x subscript n is given by the following formula. So s squared represents the variance, which is equal to the summation of the data values minus the mean of the data values squared over n minus 1, where x bar is the mean for this set of observations. The units for the variance are the units of your observations, but squared, since you can see here this is s squared. Now for objective 3, we compute the standard deviation for a set of data. Since it would be more convenient to work with a measure of spread that has the same units as our data, we'll be mostly working with the standard deviation rather than the variance. The standard deviation tells you on average how far away the observations are away from the mean. The standard deviation of n observations of x subscript 1 to x subscript n is given by the following formula. S, which is the standard deviation or the sample standard deviation, is equal to the square root of the variance. So what we're doing is we're taking the square root of the variance formula in order to get the standard deviation, where again x bar is the mean for the set of observations. The units for the standard deviation are the same as the units of your observations. So let's take a look at an example. We want to find the variance and standard deviation for the given data, 4, 10, 18, 23, and 25. So we can see here that the formula for the variance is given here, and the formula for the standard deviation is there. So the first thing we need to do is we have to find the mean, or x bar, of our data. So we know that there are 5 observations, meaning that there's 5 numbers here. So we're going to add them up and then divide by 5. So 4 plus 10 plus 18 plus 23 plus 25 divided by 5 gives us a mean, or x bar, which is equal to 16. Now, the next question, or next part of this process, is that we want to compute the deviation about the mean for which the data value, x subscript I, minus the mean, and then square these values. The completed table is going to be shown below. So what we're trying to do is, you can see here that in the first column, we have our data values, which is 4, 10, 18, 23, and 25. And then the second column represents the mean that we got from part 2. And the simple mean is 16, and it's the same for each particular item. Now the next thing we want to do is we're going to take the data value. So we take the data value, which is 4, and then we subtract the mean, which is 16, from each data value. So 4 minus 16 is equal to negative 12. Again, we're going to take 10, which is a data value, and then we're going to subtract our mean. So 10 minus 16 is negative 6. Next data value is 18. And we're going to subtract the mean, which is 16. So 18 minus 16 gives us 2. The next data value is 23. Again, we're going to subtract the mean, which is 16. And 23 minus 16 is equal to 7. The last data value is 25. And again, we're going to subtract the mean, which is 16, and 25 minus 16 is equal to 9. Now, the next step that we want to do is we want to be able to then square these values to find out what this is when you square it. So if we take negative 12 and square it, negative 12 times negative 12 gives us 144. Negative 6 squared gives us positive 36. 2 squared gives us 4. 7 squared gives us 49, and 9 squared is equal to 81. Now, when we look at these numbers here in this column, when we add them together, we end up getting 0. So this summation tells us to add this entire column to get 0. Now over here, we want to find the sum of all these items that are squared. So 144 plus 36 plus 4 plus 49 plus 81 gives us 314. Now why did we want to find this? Well, let's take a look at what this actually represents. This represents this part of our formula, which is the numerator in our formula. So once we have that, we know what n represents. N represents the number of observations that we have, which is 5. So we also know that. Now, in part 4, if we add those all up, like I stated here, we're going to compute the sum of those squared deviations about the mean, which gives us 314. So now what we want to do is we want to then solve and substitute the values into the formula to find the variance. Now remember that the sum is 314. We know the number of observations is 5, and then subtract 1. So 314 divided by 4 gives us 78.5. And therefore that represents our variance. And now we want to be able to find the standard deviation. So we're going to take the square root of the variance to find the standard deviation. So the square root of 78.5 gives us approximately 8.86.